Okay, in this section, let's talk about section 4.5, inequalities involving quadratic functions. So what is a quadratic function? Quadratic function fx equal to ax squared plus bx plus c. This is quadratic function. Because we emphasize it's quadratic, so a is not equal to 0. For a quadratic function, if we're talking about inequality, of course, we have two possibilities. One is that fx is greater than 0, or the other one, fx is less than 0. So two possibilities. Because you see here, when we fix this quadratic function, of course, we have greater than or less than. But if you do not fix this symbol, you can multiply the inequality by -1 to easily transform from greater than to less than, right? You multiply it by -1, it will become less than. So so this will be confusing. Why we always discuss two cases, greater than or less than, because less than is also achieved by greater than. So in order to avoid this unnecessary argument, we assume this a is always positive. The leading coefficient is always positive. This will simplify the rest of the argument. Okay, so from now on, when we talk about inequalities involving quadratic equations, we always assume a positive. And if you have, for example, you have inequality with a negative, for example, you have this case, you're going to multiply this inequality by -1. We multiply the inequality by -1, we transform it to be x squared minus 1 less than 0, and we will study this inequality. And these two inequalities are equivalent. Okay, so whenever you have an inequality with a quadratic equation with a negative leading coefficient, you just multiply it by -1 to make it positive. And of course, don't forget to change the direction of inequality. Okay, so from now on, a is always positive. We assume a is positive. Now let's see the example. Example, solve the inequality. X squared minus 4x minus 12 less than or equal to 0, and graph the solution set. Graph the solution set. Okay, so how do we solve it? We have some fixed steps. Step 1, we do not solve the inequality directly. We solve the equality. So let fx be x squared minus 4x minus 12. We solve fx equal to 0. We solve the equality first, which means we solve x squared minus 4x minus 12 equal to 0. This is quadratic equation. We can factor it for this one. So -12 can be written as a -6 times 2. And we'll do the cross multiplication. 1 times -6 is -6. 1 times 2 is 2. The sum is -4. This -4 is equal to this coefficient of x. So you put x here, you get x minus 6, x plus 2 equal to 0. Okay, this is a cross factorization. And by the zero product property, either x minus 6 is 0 or x plus 2 is 0. So x is 6 or x is -2. X is 6 or x is equal to -2. All right, so when you have two solutions, -2 and 6, you can also check these two solutions are called x-intercept of the function fx, quadratic function. We will see this concept again, but here we just mention they are called x-intercepts, -6 and -2 and 6. And of course, there are other concept called Y-intercept. The Y-intercept is what? Y-intercept is always f of 0 if 0 is in the domain. F is here. You let x be 0, it becomes 0 squared minus 0 minus 12 is equal to -12. So it is possibly here. You have two x-intercept, one y-intercept. You just use straight segment to connect it and naturally extend it. Don't make crazy graph, just use straight segment. You will see the graph is a V shape. The graph of the quadratic function is a V shape. We assume the leading coefficient is positive. It's a V shape like this. Okay? Okay, then the graph of fx is below the x-axis between -2 and 6. So here the graph is below x-axis. Below x-axis means the value is less than 0. This is like 0 level. Below 0 level, the function has negative value. Okay, negative value, that's exactly what we want. Okay, so the solution set is between -2 and 6. And because this inequality includes the equal sign, so you also include the endpoint, you also include the -2 and 6. If here has no equal sign, you use parenthesis. Here you use bracket because you have this equal sign. So this is a solution set. And to graph it, okay, you get 1, -2, 0, 2, 4, 6. This is the solution set. Okay, so this is our first example. The first example solve the inequality involving quadratic function less than 0, and we assume this leading coefficient is positive. The graph is a V shape. The graph is a V shape, and in this case, you find the two zeros, and between those two zeros, they give you the less than 0 solution. All right. Let's see the next example. Solve the inequality 2x squared less than x plus 10 and graph the solution set. All right, so this is inequality, but this inequality is not in the standard form. So we are going to move all the terms to left side. It becomes 2x squared minus x minus 10. You only move x and 10 to the left side. So 2x squared is kept in the left side. Because this is just movement, no multiplication, it's still less than case. All right, and then you can factor this 2x squared minus x minus 10. 2 is factored as 2 times 1. -10 is factored as -5 times 2. And then let's check the cross multiplication. 1 times -5 is -5. 2 times 2 is 4. -5 plus 4 is -1. This -1 is equal to the coefficient of x. Okay? Okay, this is good. Then you put x here, x here. You got 2x minus 5, x plus 2. Lesson, sorry. I jump a little bit. So let fx be 2x squared minus x minus 10. We solve fx equal to 0, which is 2x squared minus x minus 10 equal to 0. Yeah, the step is here. Then you get 2x minus 5 x plus 2 equal to 0. It's not here, that's here. Here we just move all the term to the left side in order to determine what quadratic function we use. And then you set the quadratic function equal to 0 and find the solutions by factorization. X is a 5 over 2, or x is negative 2. 2x minus 5 is 0, then x is 5 over 2. X plus 2 is 0, x is equal to negative 2. So you have two solutions. And based on the experience of our first example, remember we have the V shape of the graph. So it will be like this, a V shape. And then from this V shape, we can see the graph is below the x-axis between negative 2 and 5 over 2. Between negative 2 and 5 over 2. Again, every time when we say it has a V-shaped graph, when the leading coefficient is positive. I emphasize this again and again. Okay, so the solution set is negative 2 and 5 over 2. This problem, it only contains less than. Without the equal sign, you use a parenthesis. So that's why I determine the parenthesis later. Okay, if you graph the solution set, it will have 0, negative 2, 1, 2, 3. 5 halves is 2.5. 2.5. So this is between negative 2 and 5 halves. All right, so that's the graph of the solution set. Okay, so let's summarize what we have. So for the inequality x squared plus bx plus c less than 0 with the condition a positive, the graph is a V shape. We first, step 1, we solve ax squared plus bx plus c equal to 0. We get two solutions, x1, x2. Two solutions. One is less than the other one. This place, we emphasize they are two real solutions. And when you have those two real solutions, because this is less than, the solution set is between x1 x2. If here has no equal sign, this is a parenthesis. If it has equal sign, you use bracket. All right? So this is on the fixed steps. Okay, so what happens if you have a negative leading coefficient? For example, if you have negative leading coefficient, you solve this inequality. The first step, you multiply this inequality by negative 1. You change it to be less than. And then you find the two solutions. Here remember that a squared minus b squared is equal to a minus b times a plus b. So x squared minus 4, 4 is 2 squared. So x squared minus 2 squared is equal to x minus 2 times x plus 2. And from here, remember you will solve x minus 2x plus 2 equal to 0. Solve this inequality by solving the equation that you have 2 and a negative 2. Two solutions, positive here. This solution corresponds to this inequality. It has a positive coefficient. So the solution set is between those two solutions. Less than 0 is between two solutions. even though the original one is greater than 0, but after you transform it to be less than 0, you will consider this, not the original one. These two are equivalent, but you consider the second case. Okay? Okay, so next. What happens if you have a greater than case? We solve the inequality x squared plus x greater than 12. So first, you move all the terms to the left side, and then you define your quadratic function. You solve the quadratic function equal to 0. So x squared plus x minus 12 is equal to 0. If you can factor it, of course you will factor it. It's a 1, 1, 4, negative 3. 12 is, negative 12 is 4 times negative 3. You do the cross multiplication, you will get, add those two products, you get 1. So it's x plus 4, x minus 3. And you will get x is equal to negative 4 or x is equal to positive 3. Okay, once you get those two solutions, remember that it's a V shape, negative 4 and 3. So the graph is above. This time we're talking about greater than case. Greater than case, we're looking for the graph above x-axis. The graph is above the x-axis if either on the left part, either if x is less than negative 4 or x is greater than positive 3, this piece or this piece. So the solution set is less than negative 4, negative infinity to negative 4, because it does not have equal sign, you use the parentheses. Union, when you see or, it's a union. When you see and, it's intersection. Greater than 3, from 3 to positive infinity. So this is a solution set. If you graph them, it's a union of those two branches. Okay, so greater, you see here, those 2 points give you 3 parts. The middle part corresponds to the inequality less than 0. Left or right part corresponds to the inequality greater than 0. So for ax squared plus bx plus c greater than 0, here a again positive. Step 1, solve ax squared plus bx plus c equal to 0. You find the two solutions, two real solutions. Okay, then step 2, solution set is either it's less than the smaller value or it's greater than the large solution. Okay, either left part or the right part. All right, so this is almost complete. Let's discuss some subtle case. Okay, this is the third example in the textbook. Solve this inequality. Solve the inequality x squared plus x plus 1 greater than 0. Okay, the same thing, solution. Let fx be x squared plus x plus 1. Okay, we solve x squared plus x plus 1 equal to 0. This one you try it, you cannot factor it. You cannot factor it, then you use root formula. Before you use the root formula, let's check the discriminant. B squared minus 4ac. B is 1. A and C are both 1. So it's 1 minus 4 is equal to negative 3. remember that when b squared minus 4ac discriminant is negative, fx has no real solutions. It will have two complex solutions, but we don't consider complex solution in this part. We only consider real solution. If it has no real solution, what does it mean in the graph? It means this v does not intersect the graph of fx, does not intersect the x-axis. It does not intersect the x-axis, then it is always above the x-axis. So it is always above the x-axis. Always above x-axis means it's always greater than 0. So the solution set is from negative infinity to positive infinity. This is what we mean, always from negative infinity to positive infinity. All the real numbers are the solution. Okay, so if you want to sketch the graph, well, it's just, you just make it heavier. This is the whole number line will represent the graph. Okay, and the counterpart, we know x squared plus x plus 1 is always greater than 0. Then if they ask you what is the solution set of x squared plus x plus 1 less than 0, then this, because b squared minus 4ac is negative 3 less than 0, fx, you will say fx is x squared plus x plus 1, b squared minus 4ac is negative 3 less than 0, then fx has no real solutions. But this case, the graph, the same thing, the graph is always above the x-axis, then the inequality has no solution. It's impossible to make this quadratic polynomial happen. It has no solution. So the solution set, we can still discuss solution if it has no solution. The solution set is empty set. You just say solution set is an empty set. So for the discriminant less than 0, positive, everything, negative, less than 0, nothing. Okay? So that's the case. Okay, so this section is not very long. It contains less examples, but because it only have two parts, greater than 0 or less than 0. Less than 0, you choose the middle part. Greater than 0, you choose left and right part. Do the exercise. Try to understand all the steps and make your computation correct. If you have a question, ask me. Thank you.